This is my video for the 2021 Pi Day, and it is a tribute to Matt Parker, who never ceases to amaze me with his channel Stand-Up Math. I especially like his numerous attempts to calculate pi. So this year for Pi Day, I have an apple pie for you, Matt. Not a real pie to eat, but using an apple, I calculate pi not in one, not in two, but in three ways, in each of the three dimensions of an apple, if you want to say so. Everyone is welcome to join me on this journey. The measurements can be easily performed, for example, with students at school. My first approach is one-dimensional. I will measure a length. The apple is as spherical as it gets. I use a tape measure to determine the circumference of my apple. The circle has a circumference of 20.9 centimeters. And it's not easy to accurately get the diameter or the height of the apple. This attempt here is too imprecise. Therefore, I will cut it in half. Then I can better measure the diameter. Here it is 6.4 centimeters. And just to check, it really is a good measure of a circle. To calculate pi, I use this well-known formula. Actually, this is the way pi is most commonly defined, as the ratio of a circle's circumference c to its diameter d. In this case, our first approximation of pi is 3.27. My second approach is two-dimensional. I measure an area. Precisely, I want to use the surface area of my apple sphere to approach pi. For this, I first peel the apple. Then I puzzle the peeled pieces to a more or less rectangular shape on a squared paper. There it is. Now I can count the squares on my paper. My peel puzzle is enclosed by 36 times 30 squares. Now I have to subtract all the squares of the rectangle without any apple peel. I counted 580 squares, with 4 squares being 1 square centimeter. With this formula of the surface area of a square, I can now calculate pi. The result is 3.54, which is a bit too high. I might have missed some parts of the squared paper that I should have subtracted. My third approach is three-dimensional. I'm going to use the volume of my apple sphere. Obviously, I did this before I cut the apple and peeled it. To measure the volume, I see how much water the apple displaces. Then I can determine the water volume. Not easy to get all the water in the can. But here you can see the amount of water the apple displaced. This time I use the formula of the enclosed volume of a sphere. My calculation for pi is 2.86, which is a bit too small. As you can clearly see, this is because I spilled some of the displaced water before measuring its volume. Here is a summary of the three approaches. Pi calculated by the circumference, the surface area, and the volume of an apple. Determining an arithmetic mean, I get a very good approximation for pi. Most of my videos are in German, so no need to subscribe for the international audience, but a like would be appreciated. Happy Pi Day, everyone.